Hello, friends. Welcome to the ATC Double Cut. In today's episode, we have a guest here from the University of Delaware. It is John Emerson, and he's going to be talking with us about MLSN. Welcome to the show,
Micah.
John.
Thank you. Thanks for having me. Excited to talk about this project.
I'm excited to talk about it too. I saw you in Karuizawa at the International Turfgrass Research Conference in Japan, and I really enjoyed the presentation that you made about that. And I know some other people in the audience did too. We heard very good feedback from Dr. Frank Rossi about the way that you'd presented that. And MLSN can be a topic that it's not always intuitive or easy to explain. And it's not always intuitive or easy for people to understand because we've all been taught and we've done for much of our careers, we've done things in the SLAN way, the traditional soil test interpretation way. And if I explain MLSN to a professor, they often will, instead of thinking about the values as a minimum value that they want to keep above, they start thinking about this value as like, oh, now that's your target value that you want to manage the soil at that level. And the way that we calculate MLSN is a bit different than the way that people traditionally think. So it can be something that's a little bit hard to explain. What I hope to accomplish in this ATC Double Cut episode is we'll talk about it again, explain what you've been working on, share that article that you recently published in the USGA Green Section Record for people to read about that update of the project, and just talk about MLSN and hopefully help people understand it a little bit better.
Yeah, I was quite surprised after that USGA article was published. I had several people reach out to me, several professors in turfgrass programs around the United States. They reached out and they really enjoyed it. And they said, hey, kudos, good job. And so that was reassuring that kind of some of the movers and shakers of the industry took notice. And so hopefully we can start to make some changes, change some minds a little bit, and move forward with that.
MLSN stands for minimum levels for sustainable nutrition. So if anybody doesn't know, that's when we say MLSN, we're going to say that instead of speaking out minimum levels for sustainable nutrition. And what it is a modern method for turfgrass soil test interpretation. Now, this being the ATC Double Cut, we're going to give a double cut treatment to a particular post on the ATC website. I'm going to put a direct link to this post in the show notes. I'll bring it up on the screen now. And this is a post from a couple of weeks ago that I wrote after I'd seen your presentation in Japan. And this has a title, Good Turf, Bad Turf, and MLSN. Can you tell me a little bit about how your trip to Japan was? Had you been on a plane ride that long before?
No. The farthest I've been has been to Europe. I've been to Europe several times. And so that's, I don't know, 6, 7, maybe 8 hours from the East Coast of the United States. So this was my first time to Asia. But I kind of splurged on myself for this trip because I knew that the plane ride was going to be quite long. So the university paid for an economy ticket, and I upgraded to signature class with Air Canada.
Wow.
Yeah.
That's the way to fly.
Yeah. So I was. It was quite nice. It's a lot different when you enter the plane with your own. What do you call that? A jetway or the?
Yep. It's called turning left. It's called when you get on the plane, you turn left.
That's right. Well, we actually had our own. So there was an economy jet bridge, and then the signature class jet bridge. So I had my own jet bridge.
Yes,
Yeah,
yeah, right. You get on the one that goes to the left.
that's right.
That's nice. Yeah, and then you had your own pod
Yep.
to a lie flat seat,
Yeah.
very attentive service with a multi course meal and so on.
Yeah. Champagne, hot towels,
Yeah,
blankets.
that's
I've always heard people tell me that have flown first class, especially on longer flights. They're like, once you do that, economy will be very difficult to go back to. And I will agree with this because I returned to the United States in economy, and I was like, oh man, this is awful.
well, it's still pretty remarkable, I think, that we can get from one side of the earth to the other
Yeah.
safely and within 12 or 14 or 16 hours and just be on the other side of the world. That's pretty cool. And the nice thing about most major carriers that are flying those long flights is the economy class is still okay
Yeah.
in terms of leg room. I mean, for me, it's okay. I like to fly business class, but I don't always want to pay for it. So
Exactly.
so
I,
we
I think I I think I lucked out honestly because when for the flight to Tokyo, they have a bid process, and I don't know if this is the same for other airlines, but they have a bid process, and I put in the lowest possible bid that I could put in, and I still won the the ticket, or they selected me to upgrade. So I
good
thought
for
for sure
you.
that I would have to like triple my bid, or pay some exorbitant amount, but of course I had a limit to what I was willing to pay.
Good for you. All right, so the trip started off really well. Like
Yeah,
you're going there like a VIP. Um, the next best thing to flying private,
right,
and then you shot up to Karuizawa on the bullet train, I suppose.
correct. That was a first for me, the bullet train. Um, I was a little taken aback by the busyness of the Tokyo subway, and there's just a lot of people. I think what is it, 30 something million in Tokyo. I
Mm-hmm.
mean, it's there's a lot of people there, and it seems to move flawlessly, and it's quite different than the public transportation in the United States.
Yeah, so the Tokyo metropolitan area is the world's largest. It's the highest population metropolitan area in the world. So it's large geographically, and it has a high population density, and there are a lot of people. And to move all of those people around, you need a lot of public transportation. And so there are a lot of trains above and below ground, and that system works quite well. But when you get there at first, there's a lot going on, and that's why I was joking in some comments I made earlier this year. I was saying, if you're not sure where a train's going, don't just panic and jump on it, because I speak from experience. It can be a little bit overwhelming, and you're like, oh, I don't want to miss the train. I think this one's going where I'm going. You get on it, and if it's going the wrong way, you can be in trouble. But I saw you in Karuizawa, so I know that you made it up there. And
Yeah,
then you gave a presentation. Let's see. Let me look at the blog post. You gave a presentation that. Do I have a title for this? What was the title of your presentation? Do you
I
remember?
believe it was indexing the soil nutrient status of Delaware turfgrass systems.
And so what you were doing is you were presenting the results of a project that you also wrote about recently in the USGA Green Section Record. And
Correct.
that was a article that has the title Indexing the Soil Nutrient Status of Turfgrass Systems to Develop Regional MLSN Guidelines, a Delaware case study. And there's links. There's a link to that article in the blog post. So you presented this. What's it? You were presenting at the scientific conference. You had like 12 minutes to present and then 3 minutes for questions.
Yeah, that it's tough because there's I have so much to say about this topic, and you just have to be right to the point and right to the data, right to the results. And whereas coming from what I do normally in extension work, I usually have an hour, 2 hours or so to talk about whatever the topic at hand is. But here you're on a clock and you got to get to the point.
But it's when you were watching other presentations at the conference, don't you appreciate that the speakers are forced to get right to the point, and they can only, if you only have 12 minutes to present, you have to share what's really essential. And so you feel like some of the talks leave you wanting more, and you rarely feel like checking your watch. I wonder when this is going to be over. I wonder how many slides they have left. Like you don't have that I wonder how many slides they have left feeling, because you know that it's going to be over soon.
Yeah, and I think that's good to leave there with the feeling of wanting to know a little bit more about a particular topic. I think that's what makes science fun, right? Learning something new.
Now, I thought that your presentation and the way that it was at the very end of a session. So you gave your presentation in 12 minutes, and then there was time for a couple questions, and then we ended up staying in the room after the session ended because there was still further discussion about this. I wrote about one of the questions that came up in this blog post, and it was why did you only do the sampling from good turf, and wouldn't it make sense to check the soils that are producing poor turf also? What was your answer to that? Do you remember?
To be completely honest, I don't remember, but I think it was something along the lines of if we're not really interested in the nutrient levels of poor turf, because in this project, I defined what good performing turf is, right? It doesn't have nutrient deficiencies or nutrient deficiency symptoms. And so if I took poor turf, then nutrient deficiency symptoms may be prevalent in poor turf. And so that wouldn't be valid for this data set.
For the way that we do the MLSN analysis, where we're just looking at what the distribution of nutrients are in soils that are producing good performing turf, and then we shift that up a little bit and make sure that we're above the minimum value that is producing good turf. So in the way that we make that analysis, we're not really concerned about the bad turf. That's a different world. That's a different universe. We're just focusing on what's working, what's producing good turf. And that is a good, straightforward answer. I brought up, and I've mentioned it in the blog post, and I've linked to another blog post that I have explored this in more detail. There's actually a bit of a paradox that you'll find, which is that if you would do that kind of project, it would not surprise me that if you sampled good turf and bad turf in Delaware, it would not surprise me if you'd find nutrient levels actually higher in the soil under bad turf. And that's a bit of a paradox, because people think that higher nutrient soils should produce better turf. But what actually happens is turf is alive and it's growing and it's using nutrients. So the healthier your turf is and the more that it's growing, the more nutrients from the soil it uses. As the nutrients move from the soil into the plant and are removed from the system, the soil nutrient levels go down. And as you repeat this process over time, what happens is the soils with good performing turf, the soils under good performing turf end up getting depleted of nutrients faster than the soils under bad turf that's not growing so much.
Yeah.
And so you have higher nutrient levels under bad turf. And that's why for the MLSN project, it makes sense to only sample good performing turf.
Yeah, now you got me thinking. I I have access to a lot of the records from the University of Delaware soil testing lab, and I wonder if I could get a hold of them because they are broken down into good and bad turf. Um, I'd be curious to see what some of those nutrient levels are for the poor turf.
Yeah, that would be a one of the more interesting projects to do, and see if that can be documented by self-reported quality assessment.
Yeah, I think that's what I like most about my project is that the quality control is me. And whereas if someone that maybe doesn't have the same trained eye that I have or that you have, maybe they would misrepresent good or bad performing turf.
Yeah,
So
I have a high confidence in golf course superintendents or professional turfgrass managers in general to be able to identify what is good turf or bad turf.
same.
And you, as a former golf course superintendent, have that eye that I trust. So when you say that it's good turf, then that is a rating that I trust. That's always been a question that comes up more frequently than others in relation to MLSN is how did we define good turf? And in the case of MLSN, it's self-reported, but because it's all coming from professionally managed turf grass, I'm like, how can you not say that somebody that is managing turf for their career, how can they not be able to determine if the turf is meeting the quality standard that they've set or not? So to me, it's just like it's self-evident that the quality ratings are fine. In your case, you took it a step further because you restricted the quality rating to be made only by yourself, so you can expect some consistency from site to site
Sure.
as you took the samples only from good performing turf. All right, let's go through this project really quick. So you sampled from like every county, or you didn't sample from every turf grass in the state because there's going to be tens of thousands or hundreds of thousands of lawns, roadsides, sports fields, parks, golf courses. But you did do a statewide soil sampling project, and I think you mentioned that you took a lot of samples, and maybe it's hard work to push a probe into the ground that many times.
Yeah, I mean, I took 12 subsamples per sample that I submitted. So, I mean, that's regardless of the area, whether it's a green, a fairway, an athletic field, or a lawn. I took 12 samples from each sample site. I think I had 435 total samples. So you multiply 435 by 12, and that'll tell you how many times the probe went into the ground, minus the one broken probe, or not broken, but bent tip, where I hit a rock as I was using a rubber mallet. But being that this project was funded by the USGA, it had to be golf course heavy, and that's kind of what I wanted to do, anyways. And they were kind enough to say, as long as you sample, have the sample kind of leaning towards the golf course side as opposed to lawns or athletic fields, that would be sufficient. But 435 total samples. I hit every golf course in the state of Delaware. We have three counties, um, and I hit every golf course in the state except two. One was on an Air Force base, and I didn't have time to get access to that. And then another one, it just didn't work out, the logistics, because it can be kind of a logistical nightmare to get in touch with superintendents and turfgrass managers and say, hey, I need to show up and take some soil samples.
And
So it
for
can,
and for consistency, you were also leaving the grass on the sample. You're leaving that cap of thatch and living plant material at the top of the sample. You're leaving it on the sample, and then letting the laboratory equipment and screen remove that for consistency. So when you're doing that, I know from my experience, when you're out sampling on golf courses, a lot of people are really concerned about all the holes you're making in their turf, and they would rather that you're taking the grass off the sample along with some of the soil nutrients. You're taking some of the soil nutrients, some of the below ground plant parts and soil parts that for me should be part of the soil test, and you're removing it from the sample and you're putting it back. Did you run into that where people were like, hey, that's not how I want the samples taken?
there were only maybe 3 or 4 courses that kind of ushered me around and were using a divot repair tool or a knife to repair the holes, or maybe throw sand back into the holes that I from the sub sample. But the vast majority of them, of the golf courses, of course, it's not going to matter on an athletic field or a home lawn, but on especially on putting greens is where most of the superintendents may have had some concern. But there's only a couple golf courses that were concerned about it.
All right. That's good to hear. When we go do OM246 sampling, and I like to take the samples with a slightly larger diameter core. That's always a big issue, is like we have to figure out before we even get started, like how are we going to fix all these holes that we're making. I know a lot of good tricks, and I consider it to be really easy to do now, but it's always something that when people are doing it for the first time, we need to discuss. So I know when you're going around collecting all of these samples, just the logistics of that, it's a bit tricky. So you completed this project over a 1-year period or something like that in terms of collecting the samples?
Yeah, the collection was, I've got a full-time job, so I think this was maybe over like an 18-month period. Take up a couple weeks and try to get as many as I can, and then have to, devote my time elsewhere for some time, and then I'd come back to it. But maybe over a period of 18 months, give or take.
And then you ran the samples at the University of Delaware soil testing laboratory, and you got the results back, and then you analyzed them in the same way that we did for MLSN, which is basically you line all of the samples up and you say there's 1% of them that are, or you say there's like 100% of them are, let's see how we could either say they're above or below a certain value. Let's say below. So there's like 0% of them less than 1 part per million, 0% of them less than 2 parts per million. You do this element by element. Let's say calcium, for example. So you have like 0% less than 50 parts per million. And then maybe the lowest one for calcium would be like 51 parts per million. I'm just making up these numbers. So then you got like 0.07% of the samples are less than 51 parts per million. And you keep going up until you get to the highest sample, which is like 2,200 parts per million. And you have 100% of the samples are less than 2,200 parts per million. But you know that they're all from good performing turf. And so then you go down to and you find out what the 10% value is, which is just arbitrarily chosen as a number that makes sense for the original authors of this project. As well, let's say that's a good safety buffer. Let's say that 10% of the samples that are producing good turf, let's say we don't actually want to be that low. So we pick that as a minimum value that's safe. And in your case, you found for calcium the number was 235 parts per million. So you had 10% of your samples were less than 235 parts per million. 90% of the samples were higher than 235 parts per million for calcium. And that same methodology for your data set, you had 22 for potassium, 20 for phosphorus. These are all with the Mehlich-3 extractant. 34 for magnesium, 5 for sulfur. It turns out that each one of those is lower than the original MLSN, the current MLSN guidelines. Your number for potassium is lower, your number for phosphorus is lower, calcium lower, magnesium lower, sulfur is lower. And so what does that mean in plain English, that you just went and did this sampling of good performing turf in Delaware and everything was lower than the conventional MLSN guideline?
Well, to me, this, I don't know if proves, it's almost like a proof of concept to the MLSN idea, in my opinion, because it tells me that MLSN is more than sufficient to produce good performing turf in Delaware. I can't speak the same for Pennsylvania or Kentucky or Florida because I don't have those data. But I think it's fair to say that for Delaware, MLSN is plenty. And just to kind of go back to the idea that we were talking about just a second ago about the 10% value on the distribution curve. Well, even if we made, that's an arbitrary number that you and Larry and Wendy came up with. But even if you made that number 20% or 30%, 40%, it'd still be lower than the traditional nutrient recommendations or traditional SLAN guidelines.
Yeah, so this is the stuff that's fun to talk about, and also frustrating sometimes when people keep like questioning whether the MLSN type of analysis is valid or can be used, and say, well, maybe we should stick with SLAN. It's like, well, we could pick the 50% value from MLSN and make fertilizer recommendations based on that. And in most cases, it's going to still be lower than what the SLAN recommendations are. I put a link to another blog post in this blog post, so there's going to be a direct link to this in the show notes, whether you're watching this as a video or whether you're listening to this as a podcast. You'll be able to click through to this blog post, and at the end, I put a link to Jackie Guevara's research. And she did a project comparing SLAN recommendations, and then she actually applied them in Michigan to creeping bent grass and to Poa annua putting green turf. And she did soil testing and made fertilizer applications based on the MLSN recommendation. And for potassium, if I remember right, she ended up applying 3.78 times as much potassium using the SLAN recommendation, with zero difference in turf quality, zero difference in traffic tolerance, zero difference in end of the year soil test potassium. So when you apply 3.78 times as much, get zero improvement in turf quality, you get zero improvement in traffic tolerance, and at the end of the year, your soil test level is the same as when you applied 3.78 times less, then that tells you that it was just a complete waste of potassium to be applying that. And there's various ways that we can approach this, but I really like approaching it as like, let's look at what the real nutrient levels are under good performing turf in 2025 with the varieties and the way that people manage turf. And I would say that turf is managed to a higher standard now than it was 50 years ago. If we our memories might tell us that turf was the best it ever was in the 1970s, but if we look at recorded television broadcasts of whether it's lawns of cars driving down streets through American communities, and you look at the lawns, or you look at old photographs, or you look at video of old golf tournaments, or look at the Shell's Wonderful World of Golf videos, we can see what the turf conditions were like. That's the type of era when the SLAN guidelines were developed. And we're growing grass in a different way today, and we can actually go measure through soil testing what the nutrient levels are, and then we can make recommendations based on, let's make sure that we don't get too low. And that's what MLSN is. It's just, it makes a lot of sense, and I'm so glad to see that you're able to document this in such a broad project that goes across all 3 counties of Delaware.
All 3 of them, Micah.
I was hoping you were going to say there's like 27 counties or something.
No, we there's only just around 1 million people, the population of Delaware.
Oh man, so no wonder Tokyo seems so big.
Yeah, and we have 250 plus million chickens in Delaware. So we have 250 chickens per person per Delaware resident.
Wow. That's that. I thought we were going to be talking about MLSN data, but we also get the chicken to human ratio. That's very good.
Yeah.
Well, we also have talked about the Global Soil Survey and how the update to MLSN, which whenever I get around to updating the current MLSN guidelines, the numbers are going to shift to something that's closer to what the Global Soil Survey found. And the Global Soil Survey numbers are really similar to what you found in your Delaware survey, which I thought also gives some support to the numbers that you found in Delaware are not, they don't seem to me to be just distinctively Delaware type conditions. I think that's more of a global type of soil nutrient distribution under good performing turf, because the Global Soil Survey, we had samples from I forget how many countries, but definitely from multiple countries in Asia, United States, Canada, and multiple countries in Europe. I don't think we ever got anything from Australia, but we had the northern hemisphere covered pretty good. And the nutrient levels that we found in terms of the way the nutrients are distributed under good performing turf are very similar to what you found in Delaware. So I think it's pretty simple. Nutrients are pretty simple. The grass just needs to have enough of them, and that's the way MLSN works.
Yeah, I remember. I think I sent you a text or an email maybe. Once I had these final numbers after running the data analysis, and I was like, man, am I doing something wrong? And then you said, no, this is pretty damn close to what we had with the Global Soil Survey. And you sent me that data or those guidelines, and that was reassuring to me that I was on the right track.
Yeah. And what you published in the Green Section record is the initial analysis where you look at it in just basically adding up the samples.
Right.
Like I described. And we've talked a little bit about trying to account for lawn, fairway, sports field, putting green, kind of trying to incorporate some of that metadata into the analysis and doing a little bit more of a complicated analysis. And I think those numbers may shift a little bit. I don't know if they'll go up, down, just kind of randomly change. But I'm interested in doing that. So now that you've got the project completed and the data all collected, now you can work on the final analysis of the
Well,
of the data set.
I originally thought that the actual extraction of soil samples from all over Delaware was pretty difficult. Um, that was physically demanding, and I think the data analysis here at the end might be mentally taxing compared to the other parts of the project.
Yeah, science is not easy because uh, it turns out that we study something that hasn't been studied before in the exact same way. So you're breaking new ground in knowledge, uh, and so you're learning new things that you yourself didn't know before, and then in science you're supposed to communicate that, and so the form of communicating that is through some kind of well, you communicate at conferences or through trade publications, or you do the scientific peer-reviewed journal article. And so when you do that, you're struggling. I mean, it's a struggle because you're learning something yourself, and then you have to be confident that you really understand it. But then you have to communicate that something new to others who didn't do the research and haven't already gone through that journey of learning that you yourself have learned something new. And
Yeah.
and this kind of thing it really is something new. I'll make fun of the herbicide applications or something, but if you're just checking like what the timing date is for your crabgrass prevention and whether pendimethalin or a different active ingredient is going to be more effective, that it to me that sometimes is a very simple study, and it's not like breaking new ground in terms of a completely new way of thinking about something. It's just like, okay, now we see that the spring weather is more inconsistent, so we're going to double check the timing. But everybody already has the idea of like, here's the pendimethalin timing or something is it's the type of study that people are already familiar with, and it's just like an update to it. But something like this about like completely suggesting that we throw away the old way of thinking about making fertilizer recommendations, it's a little bit different. And you actually mentioned that in your presentation in Japan, and I thought it was very good. I think one of the final slides, and I think you may have posted this on LinkedIn as some of the continuing questions or what should come of this work. You question whether at universities or in usual turfgrass education of any type in the United States, whether we should even teach SLAN at all. SLAN means sufficiency level of available nutrients. Those are the guidelines that are based on, perhaps they're updated, perhaps they're not updated for the past 50 or 60 years. In a lot of cases, they're not updated very much. They're based on agricultural research. They're based on a different soil type. Now we use a lot of sands for high quality turfgrass. They're not based on research that was done in sands. They're not based on modern turfgrass cultivars. And they're also based on when annual nitrogen rates were 2, 3, 4, 5 times what is common now. Sometimes even more than 5 times higher than what we use now. And it seems pretty obvious that if you apply 5 times as much nitrogen, you're going to need 5 times as much potassium. And that's what those guidelines are based on. They're based on research done in the 60s and 70s. And yet it still gets taught. I had a phone call last week with somebody who's getting a graduate degree in a turfgrass field. And their undergraduate degree was from Penn State. And they said, yeah, they didn't really learn about MLSN at all. And you're just like, even if I just don't understand, I don't understand why we can't, as an industry, just kind of update ourselves a little bit instead of sticking with stuff that was cutting edge 50 and 60 years ago, why we can't do something that's a little bit more modern. And I'm glad that you, in your direct manner, bring this up, and you just brought it up at the International Turfgrass Research Conference and said, hey, should we even be teaching what we're teaching?
Yeah, I think for me, like the evolution of my understanding of how turfgrass grows, how turfgrass uses and utilizes nutrients from both fertilizers and the soil. And once I started to learn through just reading and studying for my job, for graduate school, SLAN began to really it just did not make sense for me anymore. And as part of my job, I have to teach that with the nutrient management program. And the entire time I'm cringing on the inside, because I know that what I'm teaching, yes, the amount of nutrients that SLAN gives to the turf is going to be sufficient. You'll never have to worry about nutrient deficiencies. But I don't know if that's like a good route to or a good mode of thinking when it comes to high quality turf grass. I think we only need to, you've said this 1,000 times, only need to apply what the grass needs, and or maybe just a little bit more. But SLAN no longer makes sense to me, and I think it no longer makes sense to other people as well. But the folks who are going to start an undergraduate program in turf, or currently in an undergraduate program in turf, I think it would be valuable for them, for their career, to understand and learn MLSN, for their nutrient management.
Thank you. I think that's about enough about MLSN. May I ask, when you were at the International Turfgrass Research Conference, did you see any other presentations or posters that you thought were particularly interesting? Any that now that I've just sprung this question on you, that stuck with you even after you came back home?
I think one that I found particularly interesting was, I think it was the Wendell Hutchins group. I think they printed, they talked about, or they covered the different species of spring dead spot, and kind of the holistic approach to address both of those species, and kind of what sets them apart, and the different management practices involved with that. And I think the reason why that kind of stuck to me was because spring dead spot and winter kill was a big problem in the Mid Atlantic this year, and so I thought that was quite interesting. I enjoyed the zoysia grass symposium. That was quite enjoyable to listen to the evolution.
I'm glad to hear that.
Yeah, you were. I think you were the chair of that, or the moderator.
I was.
I wanted to ask a question during that, but maybe I can ask you. We heard folks on that zoysia grass symposium panel, Mbika and Susanna, and there's several other folks on the panel, and they all seem to point to problems moving forward with the ability to exchange plant material.
Mm-hmm.
I don't. Is that a problem, or is there a solution to that at a local level? That's a federal problem, or that's a federal challenge, right?
Well, I don't know that federal is quite the word. It's it's the problem is your intellectual property protection, because basically the problem is, and it seems much less of a problem with seeded varieties, but when you have varieties of grass that are vegetatively propagated, once, like, that could be planted at a golf course, then somebody can go sample somebody can go take some of that grass, make their own nursery, and then plant their own golf course with it. And so now they're just planting, like, it has to do with plant breeders' rights and who's going to control that material. And so they could send me all their best varieties from the U.S., and I can say, I'm going to research these. I'm not going to propagate them and sell it. But somebody could come steal one stolen from me and then make a nursery. And that's always been a problem. It's always been a concern of certainly of people breeding in the United States, because they're doing that for money, right? So there's a lot of money involved. And so I'm shocked at how difficult it is to develop and how costly it is to develop a new variety, and you need to get that money back. So you have to protect that material. That's what I see as the problem. Like, because there's research on zoysia going on in China, Korea, Japan, Thailand, Australia. I know there's some varieties being evaluated, varieties in New Zealand being evaluated.
Are these experimental varieties?
No, like local selections. I know I've seen stuff. So people are looking at this all over, and I know there's zoysia research in Turkey. There's zoysia research in Italy, certainly, and I know there's some varieties being evaluated in Spain also. So you've got a really nice grass, and then there's all of these independent places of people are like working with varieties, and because there's money involved, and I don't know how you can ever share that material. So if you do share the material, you have to have a lot of contracts saying that, well, this material is for evaluation only. And if it's going to be used for breeding, then you're going to have to share in the future profits of whatever's developed from that. But always the problem that I see in Southeast Asia is theft. And that is the concern, that people don't want to share because somebody can just take it.
Yeah, that's until I got into this role, and I have a couple in-depth trials here on the university campus. I didn't realize how expensive it was and how long that process was to bring a grass from nothing to the market. So that could be 10 years, 15 years, even 20 years. And then you talk about the breeding. Well, that all happened prior to that window. So
and let's say let's say that they're starting off with 4,000, and that may even be a low number. But let's just say you're starting off with 4,000 plants, and you're saying, okay, we're going to try to develop a new greens type zoysia grass from this. You end up throwing away 3,999 of them. But think of all of the work done, the space taken, the irrigation applications made, the mowing done, the drone photos taken, the computer analysis of the drone images, the human checking of the varieties, the cutting those 4,000 down to the top 100, and then evaluating those for multiple years, and then cutting those 100 down to the top 6, and then you cut that down and then you go do a multi-locational testing, and you make sure that it works in Oklahoma, and you make sure it works in Southern California, and it's an incredibly costly process to develop those new varieties, which from my perspective in Asia, I don't see any value in it. No, it's not that I don't see value in it. I don't see how you can make money doing it. But the U.S. is a different market because the U.S. is very big, and apparently they plant on lawns and they build new golf courses, and people like to have the latest and greatest. But in Asia, where zoysia is native, you can get really good varieties that are already growing in nurseries, and you just plant it, and I just don't see the incentive to spend millions to develop new varieties in this part of the world.
Yeah.
So then it's like, so if you've already got such good grasses here, then
There's no incentive to take it elsewhere.
well, yeah, I don't know. It's complicated. It becomes a business issue and a marketing issue because you can certainly sell new zoysias in Asia, but I'm not sure that they're quantitatively any better than the zoysias that are already here. But I'm quite curious about whether they are. But who's going to pay to do the research to compare? It's a bit of a problem.
Yeah.
It's like, I don't know. I've been thinking about this a little bit, and if you think about ultra dwarf Bermuda grass like Tiff Eagle, I think Tiff Eagle, certainly Champion. Champion certainly is taken as a selection, and Mini Verde I understand was taken as a selection, and Mach 1 I think is a selection. Pretty much, those aren't grasses that you breed, they're grasses that you find.
Right.
You find it and then you evaluate it. And in fact, TIFF 3D, I think, is a grass that was found. It was a grass that was performing particularly well. And so then it's selected. In Asia, that's how zoysia is done because zoysia is growing everywhere. So you just find the one that's really good. And you saw Andrew McDaniel's presentation in the Zoysia Grass Symposium.
Yeah.
If you remember seeing that slide where he said we do a lot of tournaments at our golf course, and he had a drone picture looking down at the green surrounded by spectators, and there were all different kinds of zoysia on that green because it's an old green. And so you can see that some of them perform better than others. You can select those just the way that ultra dwarf Bermuda grass breeding is done, and or selection, but we might call it breeding. But if you look at what it is, it's often like taking varieties that are found to be growing well. So in Asia, we have the luxury of being able to do that with zoysia. In the U.S., because zoysia is not growing wild everywhere, they have a formal breeding program. And you're able to do tremendous things with that. I was shocked. I visited Tifton and saw Brian Schwartz. He gave me a nice tour, and I met some of the other scientists down there. And we went and looked at the type of zoysia diversity that you can get, the difference in growth habit and color and leaf texture and vigor from doing breeding by crossing this plant with that plant and then harvesting the seeds and growing it. And it's shocking how different and how much potential for improvement there is from the parent plants to the next generation. It's really good.
Quite fascinating.
It's fascinating. And so I can see why in the United States there's so much excitement about what can be done with conventional zoysia breeding rather than just selection. But all these grasses are being developed in the U.S., and then they're not being tested in the Philippines or in Taiwan or in Japan or in Thailand or in China. And in fact, they're not even being compared against the standards here. So I know you've traveled around Japan and you would have seen a little bit of zoysia in Kyoto and a little bit of zoysia in Tokyo and a little bit of zoysia in everywhere you went because it's just there. And nobody's really clamoring to say this zoysia is not good enough. We need a newer one. No, because it's just there and it's doing just fine. And that in the U.S., it seems like everybody wants a better one because it's something that's completely new. I think it would be nice if we could compare against the standards in a given location.
I want to back up just a second. The thing that stood out to me the most for my entire trip was when I arrived in Karuizawa. I thought when I got off the Shinkansen train, started walking towards the bus pickup, that I got out of the train, it was 75 degrees, or maybe even less. It
Mm-hmm.
was overcast and misty and foggy. And I was like, oh man, this is perfect. Cool season grass. I thought when I'd get off the bus at the hotel, I'd be surrounded by tall fescue, fine fescue, ryegrass. It was wall to wall zoysia grass, and that was the most fascinating thing to me that I found in Japan.
Well,
What
it's
if we're talking about grass?
yeah. So I've got another blog post that I wrote after the conference about the temperatures, because a number of people commented to me that it was warmer and more humid than they expected. Because it turns out that if you look at the latitude of where Japan is, it's something similar to North Carolina, South Carolina, Georgia, Florida coastline. That's what it's like. And we wouldn't expect to see cool season grass in those areas. But sometimes people go to Japan expecting to see cool season grass, but we're at a latitude that's more similar to like Charlotte, North Carolina or something. So you can have bent grass greens, and in Japan on golf courses, they do have bent grass greens, but it's really common to use zoysia. So zoysia japonica gets used in the mountains and in the colder areas. And unless it gets really, really cold, like in Hokkaido, or the very northern part of Honshu Island, the main island of Japan, that's where you'd use cool season grass everywhere. But even up in Karuizawa, which is a lovely mountain resort near Tokyo, and the elevation is about 1,000 meters, about 3,000 feet elevation. There, the base grass is Zoysia japonica, and it does have some cool season grass mixed in with it, and you'll see cool season weeds. But on the golf courses there, they're using Zoysia japonica tees, Zoysia japonica fairways, Zoysia japonica rough, and creeping bent grass on the greens. So for professionally managed turf, they're not mixing in the cool season grass. But if you go look in a park or something, you will find a mix of Zoysia japonica and some fine fescue and stuff like that.
Yeah, it was interesting to me.
It is interesting, and it's been interesting talking with you, John. We've covered MLSN, we've covered a bit of Japan travel, and we've covered the Zoysia Grass Symposium and a little bit of that excellent conference. So I really enjoyed the conference. The next one is going to be 4 years from now, which is 2029. That's going to be in Guelph, Ontario, Canada. I'm planning to attend, and I hope a lot of the listeners will also consider attending, because I think it's going to be a very, very interesting international turfgrass conference again. Before we end, though, I'll ask you one more question. Which direction flying has worse jet lag for you? Flying from the east coast of the United States going west to Japan, or flying to the east going from Japan back to the United States?
Oh, this is a no-brainer. It was extremely difficult for me to readjust when I came home. So coming from Tokyo back to the East Coast of the United States. So it's like essentially you do. So I left Saturday at maybe like 5:30 p.m. Traveled for approximately 15 hours, and then I returned to Philadelphia, Pennsylvania, and it was 9:30. So only 4 hours had passed. So I felt like I did Saturday twice, and it took me almost a week, like to get back to where I was feeling normal again.
Yeah, that's been my experience also. Flying to the east is typically more difficult. But well. It's a good thing that we didn't schedule this for last week, so you got your entire week to
Yeah,
adjust before we have this call.
I was gone for almost 17 days, 5 days or 6 days for the conference, and then 11 days of vacation. I was quite tired when I got home.
You have any bad meals?
Not a single one.
That's cool. Yeah, it's. I tell people, like, you can definitely find bad food in Japan, but you have to really look for it. You have to know what you're looking for and seek it out, because the baseline food is going to be pretty decent.
Yeah, the best meal that I had when I was in Japan, I had a Kobe beef fillet. It was quite expensive, but it was worth every dollar that I paid for it.
Cool.
It was amazing. It was the best steak I'd ever had.
That
And we're not where I had that. I had that in Kyoto, and I don't think Kobe, Japan, is maybe an hour from
hmm
Kyoto.
Yeah, it's nearby. Well, yeah, Kyoto has some nice restaurants. Yeah, Japan's a lovely place. I encouraged a lot of people to go to that conference because a lot of people want to go to Japan, and then this seemed like a perfect opportunity to go on a business trip, accomplish attending accomplish what you want to accomplish attending a international turfgrass conference, which is just a superb conference, and then it's a chance to be in a country that a lot of people like to visit. So I was glad to see so many students attending the conference, so many professors attending the conference, so many extension agents like yourself attending the conference, and so many golf course superintendents or sports turf managers also attending the conference. It's really a nice mix of people,
Yeah.
sod producers, just it's a once every 4 years gathering of the international turfgrass community, and it's fun. It's
I was
different.
surprised. I was
It's
surprised there on how many actual practitioners or turfgrass managers were there, because like I was expecting it to be similar to the Tri Society agronomy meetings in the United States, where I've never seen any superintendents at those meetings. Maybe they are, but I just didn't know them. But I thought that was quite nice to see some practitioners there.
yeah, it's something that I hadn't thought of before, and then in the previous conference, which was held in Copenhagen, Denmark, they had an entire day devoted to with a special session presenting some of the most practical and cutting edge research that would be relevant to practitioners, to turfgrass managers. They had an entire day devoted to that, and that room was standing room only, just packed. It was really the highlight session for me of that entire conference in Copenhagen. And I thought, you know what? What a great chance to come hear about the cutting edge research from the very people that are doing it. And
Right.
and so after that, I started recommending to people, you should, especially if you're from the southern hemisphere, it's the middle of your winter. So if you're from the southern hemisphere, you can go to Japan, and it might be a good time to attend a conference where you see people from Australia, New Zealand, South Africa, South America. If they're going to the GCSAA conference in February, that would be in the heart of the sporting season,
Yeah.
heart of the growing season. It's a bit more difficult to get away. So I was glad to see so many people were able to attend, and people from Europe, Dubai, Australia were all well represented.
Yeah. It was it was enjoyable, and I'm glad I went, participated, learned a lot of new things, and I look forward to the next one. It's much closer to the home. The next one is much closer to home.
And I get to deal with that long
That's
flight,
right. That's right.
but maybe I can get a expensive plane ticket. All right, John. Thank you so much for joining me today. Thanks everyone for listening and for watching. I promise to be back again soon with more turfgrass information. We will go ahead and sign off now for ATC from Trong, Thailand. I'm Michael
Thanks,
Woods.
Micah. Appreciate
Thanks,
it.
John. Bye
All
bye,
right.
everyone.